Okay, so this week we're going to begin something new called resampling methods. Before introducing resampling methods, let's consider the road so far. In the past 6 weeks, we have learned about a few things. We learned how to generate random samples from a given distribution, and we have also learned how we can use the random samples drawn from a given distribution to do Monte Carlo simulations, which is useful for approximating the sampling or the null distribution of a statistic. Our statistic can be any function of our random samples, usually denoted by x1 all the way up to xn. So this can be an estimator for a parameter of interest, theta. So the estimator is usually denoted by theta hat. It can also be a test statistic, which we denote by t, which is really useful for doing hypothesis testing. So when we know the underlying distribution of x, our samples, then we can draw directly from x and then simulate the test statistic or the estimator, so the statistic we have. And then the random values that we have obtained for the statistic will approximate the sampling distribution of this statistic. And by knowing the sampling distribution, we can do many things. We can approximate its mean of the distribution, the standard deviation or the variance of the distribution. We can also approximate all sorts of probabilities, which is useful for figuring out things like confidence level and for testing hypotheses. Well, one thing you might have noticed is that applying all of these methods, so generating random samples and Monte Carlo simulations, requires us to know what is the underlying distribution of our x. In other words, we need to know what is fx to be able to draw samples from x. And we need to be able to draw x to be able to transform them to the statistic t. Well, a question that would naturally arise is, what if we don't? If we don't know the exact distribution of x, can we still approximate the sampling distribution of a statistic, which is a function of our IID random samples from this unknown distribution? Well, this is where resampling methods come into play. Resampling methods treat a observed sample as a finite population. In other words, what we have is our data, which are IID random samples of size n from an unknown distribution fx. Instead of sampling directly from fx, which is the distribution we have no idea about, we instead draw samples from the finite distribution of the random observations of size n we have obtained. So, by using resampling methods, random samples are generated or resampled from the observed sample to estimate population characteristics or make inferences about unknown parameters. Resampling methods are often used when the distribution of the target population is not specified and the sample, in other words, the data, is the only information available to us. This week, we will introduce one set of resampling methods called the bootstrap. The bootstrap was proposed by Bradley Efron in 1979. And I included a link to Efron over here. He is a very prominent statistician, and he is also the advisor of many other prominent statisticians like Tip Shirani, who wrote the statistical learning books. So bootstrap is one of the, I guess, the very important findings or new methods in statistics in the 20th century. And for developing the bootstrap methods, Efron was recognized with many national and international awards. So if you're interested in learning more about the rationale behind bootstrap and the history behind it, You can go to Brad Efron's site or just search on YouTube interview with Brad Efron, and you can see that he actually completed many interviews with different channels where he talked a little bit about the intuition and the history behind Bootstrap. This is just something you can look up if you're really interested in this. Okay, so what is Bootstrap? The basic idea is that given a sample of size n from X, whose underlying distribution we have no idea about, one can resample with replacement from this sample of size n and estimate the sampling distribution of any statistic or estimator. And this does not require knowing the underlying distribution or the CDF of X, because we're just drawing samples from the finite sample of size n we have. We're not really directly using fx when we draw the random samples. So Bootstrap is one method that can be used for resampling. In next week's lectures, we will talk about another resampling method, which is actually developed earlier by John Tukey, and that's called the jackknife